Thank you so much for the opportunity to present some of the work we did with the SENTRY program. This is a summary of our work on digital twins in support of crowd evacuation research. This is a joint collaboration between several professors at Rutgers and also one professor from NJIT, Dr. Jie Gong, me, Dr. Roberts, and Dr. Schwartz. Just a quick summary of what actually is the research and development effort in this project. The first one, we are targeting some of the deficiencies in the existing crowd simulation models, especially in terms of they are mostly designed to simulate a normal crowd, and it was designed for offline simulation, not really trying to target any real-time decision-making support functionality. And most importantly, they're only targeted to calibrate macroscopic level accuracy, meaning general flow count, density, those type of aggregated counts stats are accurate. At the meantime, they're designed more for long-term facility performance level of service evaluation versus actually for more towards DHS applications. Last but not least, there's if you want to simulate some of the soft target threats that we're targeting in this program, it is we need to build from the ground up for any of those simulation models. For our development, what we are trying to accomplish is, first one, we are trying to target pedestrians and crowds during emergency. So trying to calibrate special parameters for those situations from field data. And then using real-time digital twin technology to create crowd simulations that can achieve trajectory level consistency. That is actually can move people exactly as they were in the field, simulating those behavior. We want to achieve the simulation in loop capability to have real-time simulation decision support, and looking at create customized threat mitigation scenarios. Our goal is to be able to perform another 1 year of R&D to potentially reach a pilot. We do have multiple research tasks that are still was not totally completed, and at the meantime, we also accumulated quite a lot of field data and for different applications while we are temporarily away from the SENTRY program. All right. Just a quick overview of digital twin technology. This is a technology that we're trying to mimic what's in digital space, what's in the physical space, to provide a potential what-if scenario evaluation, and to be able to evaluate safely in the digital environment of potential physical dynamics in response to different vulnerabilities, and look at potential mitigation solutions. This is through the SENTRY program and also additional projects that the PIs had with different agencies. These are the full portfolio of the application and data set we have created so far. This includes the two sports event ingress-egress crowd at Rutgers Stadium, a digital twin created for our Weeks Hall building, one of our new School of Engineering building, two NJ transit stations, and also collaboration with MetLife Stadium on the data collection during the Argentina-Canada Copa America game. And all of the bottom three all have implications for the upcoming FIFA World Cup 2026. I wouldn't go into too much details, but these are several pipelines that we have been we developed during the SENTRY project. The first one is the creation of the digital twin. So you can see essentially the whole process of going from drone and LiDAR sensor-based 3D imaging and collecting the full point cloud of the stadium, to converting the tens of thousands of points into actual objects. We call it building information model. And then from there to create, put that in the general context of the entire environment to simulate an ingress, egress with different mode of transportation. This is another pipeline that we developed for the pedestrian crowd simulation. So from the digital twin created, what we established is the ability to calibrate the crowd simulation model, especially pedestrian behavior, based on field trajectories that we collected. And also, at the meantime, based off the building information models that we created from the point cloud, creating the proper, I call it knobs, essentially walls and channels and routes, so that we can establish pedestrian simulation. Last but not least, we implemented the GPU accelerated technology to be able to simulate large cloud. This is we'll show you a quick demo at the end about 50K population for their movement in and around the stadium. This is another very important component. This is for the threat and patrol potential impact modeling or countermeasure modeling. The core of this is actually what we developed from our transmission research on line of sight simulation for sensors and human perception in traffic simulation. We actually extended the ability to simulate the full line of sight with the background model from the beam model of the full stadium to understand where are the potential threat locations under direct line of sight from shooters, from projectiles, from explosions. So these are the threat simulation. And then on top of that, if we reverse the perspective, looking at the line of sight of security officers, patrol officers, we can correspondingly create essentially the patrol coverage area, security coverage area analysis. So this is the third pipeline that we created to support the full research. Right. So this is the simulation of 50,000 patrons. So from 10,000 to 52,454. That's the full capacity of the Rutgers Stadium. So we were able to simulate the evacuation scenario. This is assuming a explosion condition from the center of the stadium. Proposed future work plan, if we were to get additional funding, first we want to just make sure, even though we were temporarily away from the SENTRY program, but all of our professors has been working on very much related topics and research, and the data collection that we obtained during the SENTRY program has been growing, and the application has been expanding. But if we were to get additional funding, we will be able to further kind of perform more integrated research to complete the 3 pipelines that we started. And then using the upcoming FIFA World Cup event and our current deployment application, especially at the transit station, and also potential collaboration with MetLife Stadium, to gather a very useful data set that we can take home and complete our modeling to create some useful tools for future usage and applications. So these are some of the sample works that's actually ongoing. So including the processing of recently collected from last November Rutgers Stadium ingress egress data. This is a more competitive game compared to the 2022 Penn State game. So we do get a large egress crowd for us to process. And then the FIFA World Cup preparation in collaboration with NJ Transit. This is actually an ongoing process. We will be able to collect high-resolution pedestrian activities at these critical transit stations for further analysis and security applications. Last but not least, there's some recent development related to origin-destination data collection to understand the crowd's destination choices, region choices entering the transit stations for a upcoming bridge cutoff events. So.